There's yeah, a bit Arabic word that I still remember. Yeah, on top of whatever we use in praying in salat. um, okay, I think hopefully everyone still remember last week we decided to start this class at 20 past 2 to give you time, because quite a number of you saying that you guys just finished classes and need times, you know, to praying, to have lunch. Okay. Yeah. Just give me a second. Yeah, forgotten to record. So now we are on recording. Shall we wait or what? How many students now? 18. Hmm. Ah, come on. Do I still need to wait? Okay, I think I just started. It's already. I think I give more than enough time. 20 minutes past 2 already. Okay, class. Before we continue our chapter, just for some housekeeping messages. Yeah, as usual, please don't forget to what this one. Your attendance, please do so. Yeah. One. Second, while you do checking your attendance, okay, you might notice I just uploaded this. This is textbook. Okay, well, I'm not promoting piracy. Okay, this is only for your reference. Okay, please do not pass this around to any of your friends. Not even the friend in the same course. Yeah, if they want, just get it here. Okay. Um. Okay, what else? And I also uploaded some more. Okay, because this book actually, so this book actually comes with their own slide, which is some, which is some of the slide is actually similar to what we have discussed before, but I also uploaded back to according to related chapter as additional information. So you should read them. For example, I uploaded where is it now? Here, chapter 1 preliminaries from the textbook, and this one taxonomy. Yeah, from the textbook. So as for today, we're going to discuss maintenance process. That one is taken straight away from the chapter 3 of the newly uploaded textbook. This one, chapter 3, maintenance process. But for configuration management process, will be from another textbook. This one's from software engineering textbook. That I believe you're supposed to already have this textbook because this Somerville textbook. Yes, no. Do you have this textbook, Somerville, software engineering?
No.
Yes, doctor.
Okay, good.
We used to borrow from the library when we needed it, but now cannot.
Yeah, it's Google somewhere.
I downloaded it.
Okay. Yeah, I just don't want to mention it, but yeah, it's available if you can find it. And now, as I said before, Somerville textbook is kind of a must for software engineering students to have this textbook. Yeah, I did tell you before that I still have the book that I bought when I was at your age. When I still use it until now. I still have it until now. Yeah, the first versions of the Somerville textbook, more than 20 years. Oh yeah, now it's 2020. More than 20 years old. That book would be older than your age, I guess. Okay, so for today we're going to discuss on this on the maintenance process, but portions of the maintenance process is actually somehow is overlap with this one, configuration management. So we'll see then on how we can continue with this. Yeah. Okay. This one. So first, let me share you my slide. Okay. Again, I uploaded our textbooks there for this slide, so you can read the details information if necessary. But as for now, just listen to my lecture because I'm going to simplify so that it will be easier for you to follow this chapter. Okay, chapter 3 is who's that? Can you mute your sound if unless if necessary you want to talk, then you unmute. Yeah, otherwise it will be disturbing. Okay, chapter 3 is about evolution and maintenance model. Okay, so far we have discussed about some maintenance concepts. Okay, how the maintenance is in practice by the industry. So this chapter is we're going to discuss this in more organized way, in more academic way. Yeah. Okay, so this is the coverage of this chapter. Okay, we're going to discuss about the general idea. Okay, some of them has been discussed before, but we just refresh it today, no problem. And then this is the process, the stage model for CSS. CSS actually refers to closed software something. But anyhow, this is non-open source. This is open source software. Yeah, closed software system. Sorry, closed software system. Okay, this one open source software system. I'm forgotten what was the FL, because obviously the author of this book still using the old term FLOSS. Yeah. But in the textbook they they referring they have this full terms. I just forgotten. But this is actually open source software. So now we're comparing between closed software and then closed source software and then open source software. So why do we need to refer to compare this? Because in software industry, there are two mainstream. One is open source. One is also called as proprietary or closed source. Okay, proprietary is the software that you buy normally for it, such as Microsoft Word, Microsoft Office, whatever apps out there. While open source, the one that you get it for free. Like, but it's not the freeness is not all. But actually, in open source setting, software is developed as a collaboration between programmers from all over the world. Okay, and in comparing these two, the first one, the first one is it's like is totally contradict than open source. Okay, the first one seems to be more organized, seems to be more proper way, has a clear stage, um, and the other one, it's like a rumble. Do you know what is rumble? Everyone comes in and develops something and somehow, and then in the end produce software. Okay, in comparing these two, but the interesting fact about open source software, even though it is looked as a disorganized rumble development, okay, but somehow open source software managed to produce very powerful software. Yeah, did I mention this before? Yeah, some of this software you might already familiar. It's not only open office, but they come with a very powerful software, such as the browser that we use nowadays. Okay, is open source software. Was the Mozilla Firefox, and then even the original drone system, or they call it what they call anyway, it's automatic automate very powerful drone system used by United States Department of Defense. Last time was actually open source software. And even Apache server, one of the most powerful web server, is also open source. Okay, so this just to name a few successful project of open source. Okay, because when comparing these two, this is just a kind of challenge for the first one. Okay, because the first one is organized, very organized, very staged, very manageable. The other one is Rumble project. This one open source, but then even this one managed to produce powerful, high quality software, and even in some cases even better than this one. So that's why now software engineer are also focused on this one to see, okay, how the best practice in this can be also implemented in here. Okay, even in one book it is mentioned the in one book they are comparing between these two. This one is called as the cathedral. You know what is cathedral? Cathedral is because the book was written by Englishmen, European. Okay, the cathedral is church. So when it is says church, means that everything is in proper in proper uniform, in proper what they call step process, while the other one is called as market. So market, people comes and go, and we don't know who comes in, who comes out, but in the end, still producing powerful software. So that's why in most of the software engineering study, we have this kind of comparison. Okay, so next is about change mini cycle model, because in software maintenance, as if that we have another round of development inside development. So that's why they called it as mini cycle. Yeah. So we're going to discuss that, and the rest is maintenance process. Okay, we have two type of processes. One is the IEEE and the other one is ISO. Anyhow, both of this is the same. It's just that IEEE explain process in the form of stage. Okay, the one that we used to explain as before. We have stage, we have what they call increment, we have what they call agile in the form of stage. While ISO explain this in the form of process. It's basically the same. It's just a matter of grouping, just matter of abstraction is slightly different. Okay, the last portion is software configuration management, which will be covered in the following chapter. Okay, what else? Yeah, and one more thing that I want to highlight while I already presented to you the framework, no, the teaching plan of this course. Okay, if you might notice I think I already mentioned this before. My slides title somehow is not 100% according to the teaching plan, but anyhow I will make sure the coverage is actually following all whatever decided in teaching plan. Yeah, because the reason why, because I take my sources of slides from various sources. Yeah, so somehow I will choose the best. Well, I have several textbooks, several resources, so I will choose the best, which I think is the most what do you call interesting, most factual, okay, and mostly practical for your syllabus. Okay, so yeah, so things like this happen. Okay, so this software configuration management will be covered in the next slides, sorry, in next chapter. And also the next chapter of the will be presented, the one that will be presented in Somerville slide is also covering next chapter in our syllabus, which is regarding software change management. Yeah, so basically software configuration management and system management is in the same slide for next week. Not next week, the later on Wednesday, I guess. Yeah, hopefully. Okay, so let's go to this first slide on general idea. Okay, as I already explained before, SDLC, even though, as you might understand, it's divided into how many stages? 5. PADIM, planning, analysis, design, implementation, maintenance. PA. Okay, 5 at least. Yeah, but all of them is grouped, but is a group into two major group: development and maintenance. Okay, so this is development, and this is maintenance. Okay, maintenance somehow only small, as if as a small stage, but then ironically, look, it's consuming, as I explained before, operations and maintenance consuming 67%. In some books, it even mentioned up to 80%. Only 20% is development phase. While you guys might so concerned about design, about coding mostly. Okay, most of the people out there they focus about coding. Well, actually, maintenance is the key of the successfulness of your project. If you fail in maintenance, you might fail the whole project. Right? But anyhow, to have a maintenance phase, you need to have development phase. Otherwise, how can you maintain something which is not exist? You need to create the software first, and we have maintenance. So it's actually comprehending each other. But it's just that maintenance is always underestimated, always overlooked during estimation, and that makes the one of the factors why lots of software projects out there fail. Okay, so operations and maintenance covering 70%, almost 70% of the whole software development stage. And as we all and we already discussed before, these are some maintenance unique characteristic. You even already answer what quiz questions related to this, I guess. Yeah, but this is just slightly different than what we have discussed before. Okay, just maybe some refreshments. Sorry, some so sorry. So just to refresh your whatever you know. Um, one unique characteristic, software maintenance have constraint of an existing system, while software development started from zero. So when we have a existing system to be constant, so it means that we cannot fix things as we like. We have to consider the existing system, existing structure. So we need to understand the whole code, the big the big picture first before we can fix them. Second, maintenance normally shorter times. This one I think new facts. Maintenance is normally take shorter times compared with normal development. For development would take months or years, but maintenance, okay, some users might expect us to fix things in hours. Believe me, it's happened before. Yeah, they expect us to fix things in hours. They think it's just like as simple as changing format in a later. But actually, we to fix things in software is beyond. It's not only as simple as that. Okay, another different available test data. In software development, test cases are designed from scratch because they developing something, and they develop test cases based on whatever they develop, whatever they put in specification. While for software maintenance, because we have the first constraint based on the existing system, we are limited to use test cases, okay, previous test cases, or we call this subset of the test cases that produced in during the development. And most of the time we need to repeat the same test cases, okay, which is we call as regression testing. So what is regression testing? Basically, regression testing is that testing that we do after we fix one component. Yeah, we fix one component, we put back together with another component, and we do one small integration testing. So that one is actually regression testing that repeated against, just to see how newly fixed item work well with the whole component. Okay, so with this concept, okay, so with this concept, um, Basili, okay, such, suggest three process model for maintenance. Okay, who is Basili? If you Google about Basili, he's a well-known professor in software engineering. One of the well-known professor. Even a lot of my research, my PhD work last time was have a lot of influence on this guy, Professor Basili. Yeah. Okay. So he suggests there are three process model for maintenance. Okay, name as a quick fix model, iterative enhancement model, and full reuse model. So what is quick fix model? So you can read here. Okay, anyhow, I give you what 1 minute to read this part, this portion, please. Okay, quick fix model. The first one is the one that mostly popular nowadays, I guess. Yeah, because I believe agile approach is actually utilizing this technique. So this model, in this quick fix model, so necessary changes are done quickly straight to the code, and then update the related documents, okay, related to that particular code that we fix. Okay, quick fix model. Whereas iterative enhancement model, so in this model, we change from the topmost abstractions, okay, the highest level document. So what is the highest level document for software development? On top of software plan, okay, we start with software requirement. Yeah, so let's say for any changes, any change request, first we go and check into the software requirement, SRS, and then change that part, update that part, and then we further change on SDD, software design description, and then after that we change the source code. Yeah, so this is what you call as iterative enhancement model. Okay, anyhow, we're going to explain this later. And then another one is full reuse model. Okay, in this model, a new system is built from component of the old system and others available, whatever available in repository. Okay, this is full reuse model, full reuse whatever component left in the inventory, in repository. Okay, so we have these three model. Okay, the first one, quick speed model. Look, while you can read here. Okay, okay, I give you 1 minute to read this line. Okay, here for quick fix model, look this part. Okay, this is imagine we have this old system and then new system. How new system is created from old system? They go straight away to the code. Okay, they go straight away to the code and the code is updated, and then accordingly another thing that related with this portion of code, for example design, okay, and then go to higher level requirement, and as well as related testing is done. Okay, so this is quick fix model. So it's more on the, if you understand about bottom up approach, so this is bottom up. Yeah, we started from the lowest level, which is the code, and then move outward to higher abstraction, which is including testing and design, and then to higher abstraction and another higher requirement. Okay, so this one is quick fix. So we go straight to the code and then update whatever necessary document related with that. So the second one is iteration. But to explain that, okay, we need to discuss on this the relationship between iterative and increment. Okay, incremental. Okay, perhaps you understand what is iterations. What is iteration? Iteration implies on the cyclic. Okay, things that we do repeatedly. Okay, so as well as in software development, a lot of technique is actually using this iteration, while iterative, okay, iterative is based on the scheduling. So iteration was used in iterative methods. Okay, so means that some sequence of the process, some sequence of the steps, okay, are done repeatedly, iteratively, okay, according to certain scheduling. So in the long run, this will what they call will quickly produce software, and not only produce but revising parts for the next improvement will be done, what they call will be done together, and at the end will produce high quality software. Okay, and then this iterative approach, okay, also when this iterative approach is used to develop to develop all requirement in according to certain prioritizations. Okay, we develop one by one until everything until the whole requirement is complete. Then one is called incremental. Yeah, this is the one that we do in agile development. Okay, so this is basically iterative, the relationship between iterative and incremental. Okay, so in iterative enhancement model, so what we do here, as I said before, we started from the highest level abstraction, which is requirement. Okay, this is old system, this is new system. So we're going to analyze from the highest document, in this case is requirement, and then based on the request of change that we get, so we'll see which requirement, okay, which is fit with that change. If necessary, we might change this requirement, and then we go downwards, change the design, and then change the code, and then do test and then analysis. So with that, okay, with that steps, we're producing new versions of system, and that is happen again and again. Okay, so this is iterative and enhancement model, okay, which is in reuse oriented model. Okay, second, okay, so this approach, okay, can only be done with assumption of everything in repository is still exists. So means that, okay, the repository for this one, for the requirement is what? SRS. This one is STD. This one is the source code. This one, SDD. Okay, SDD. Yeah, software design descriptions. Sorry, software test description SDD, and this one, SDD, software design descriptions. Okay, but somehow it's in most cases what I said. If you still remember last several weeks, what I said. Most of the time on the source code is live. Most of the other document has gone, either gone or not even created before, or maybe none updated. Okay, so in that situation, we might do what? Guys, are you there? In the case that we only have source code, what we should do? Are you there?
Software reverse engineering, Doctor?
Yes, good. So in that case, yeah, we do software reverse engineering. Okay, we do reverse engineering and re-engineering. Okay, they are different terms. So this is what it's explained here. So repository with the assumption that repository is always there. So this is full reuse model. Okay. Okay, next is the discussions on the stage model for CSS. And I think this is already has been discussed before. Okay, in normal in closed software, closed source software. Okay, we have this stage. Okay, this evolution stage. What happened to the system? First, we have I think this has been discussed before. If you still remember, we started with the initial development. So the software has the software. At this stage, at the end of this stage, initial development, software exists on its original features, and then the system or the software will go through a stage that we call evolution, and during this time, there are lots of requests of change, and the software is evolved. Evolve here means there are changes in terms of its original features, original requirement. And then after that, what happened? There are the software goes into next stage, which is servicing. At this stage, no change happened in terms of requirement, in terms of features, but servicing means just to make sure all the whatever features do at that moment is working. This is just to keep working whatever they has. And finally, phase out this is the time to change, okay, to change or replace the software with the new one, and there are some technique for this phase out. This has been discussed before. So this is what happened in closed source software. Okay. So this is so this diagram explaining whatever we discussed just now. So we have this initial development and then evolution stage. So this happened, okay, again and again until one time there's nothing possible to be changed. Maybe because of the lots of reason, technology is already what you call is already eradicated. People what you call the new business, for example, is totally changed and somehow cannot be coped with the features. So what happened during that time, just to maintain the functionalities, and then finally phase out and before close down. So this is happened, and the innovations of this is this one. Okay, this is basically still the same. Okay, but in this case, look, we have initial development, then we have first version. Yeah, during these evolutions, okay, we keep updating, we keep have to have several versions. For example, version 1 and version 1 goes through servicing and then phase out and then close down. So the same goes happen to the next version when version 2, and then so this is the one that one of model that I think lots of stuff happen nowadays. Give you example, lots of mobile app, for example, are actually having in this model. Yeah, the Android apps, mobile apps. If you notice, for example, what phone you use. Example, Samsung. Yeah, Samsung. While Samsung might have lots of model, for example, but the evolution happened to each model only on until certain level before finally they move. They totally they call it as unsupported. So this is also happened to iPhone, to a lot of software nowadays. Yeah. Okay, and this is also explained to what to a loss of Android versions nowadays. Yeah, we have lots of flavor. So all of these versions somehow will be phased out. We will be closed down. And then we also have this open source. So what's the difference between this one and the previous one? Can you suggest? Class, what's the difference? What's the difference? This and this one. Look, what's the difference? This one comes with a lot of this. Unsure.
It goes back to evolution again, while the other one is just one straight line down.
Yeah, yeah. As I said just now, this one is very clear. Okay, the face is very clear. Okay, this is what I said is very in organized way, organized process. Everyone is clear what they're doing. But for the open source, okay, as I mentioned before, developers for open source comes and go. I give you example. Okay, comes and go. So the evolutions happen. Okay, sorry, the stage happen in a bit different and amazing way. Example, it's not only happen during evolution, but as well as happen during servicing. During servicing, it's supposed to be only maintaining whatever current features, is it? But somehow during servicing, this is what happened in open source, might also return back to evolution. Okay, and why they put as this one, they mentioned here as a 3 difference. You can read that. But I just want to highlight this. Why this is in a dash like this? Because this is something that on what you call they're not clear. Okay, why this is happened? Because in open source setting, developers comes and go. Okay, and they have thousands of developers, and most of them, according to study, is a very skillful developers who join this open source community. Why? Because this kind of project is basically a kind of token for them, a kind of something to be proud of. Yeah, so that's why among these powerful programmers, they enjoy to join this open source project even for free, no fees, no payment, just a kind of product, kind of token. Okay, so when we have these programmers comes in and go in, so that's why they have this kind of changes. Yeah, because this only what you call it, only estimated. Okay, because this is some type of the software for open source has been evolved. Okay, this one is clear, but sometimes some type of the software is even already, people are think that they're already there, but somehow suddenly come back. Okay, so this is what happened. So I give you example. Linux, do you know Linux, is it? Linux was the open source versions of Unix. Okay, developed by who's the inventor of Linux? Khaironi Yatim Sharif. Is it? Guys, serious? Are you really with me there, or you guys just nobody there? Okay.
We are here.
Okay. So okay, so you know the original inventor of Linux is called Khaironi. No, it's called Linus Torvald. So Linus Torvald was the person who initially developed Linux, but then the rest evolutions of Linux, okay, it's not by him. Yeah, it's done by lots more, thousands of programmers out there. Okay, what I read somewhere, it's just that Linus Torvald these days he only deciding on the directions of the whole development, but the evolutions and servicing just happen as if that happened by itself. Okay, And until now, how many flavors of Linux that you know? How many versions of Linux? You might know what.
A lot of
Yeah,
distributions, doctor. Maybe
yeah,
like the most famous is Ubuntu.
yeah. Most people only know maybe for about 10 version, 10 flavors. We have
Yeah,
Ubuntu, we
but
have we have Kali, we have a lot more. Fedora, what's Linux, what do you call? Yeah, lots more. But most of people only know for about less than 10. But last 10 years, when I checked, this is what last 10 years, they have basically more than 100. They call it flavor, 100 flavor of Linux. Can you imagine that? So this is what is meant by here. Even some of the flavor for them might be already dead, but somehow some people who are interested in that particular flavor might make it up again. So this is what happened for open source community, open source software. Okay, so that's comparison between that two. Okay, next we're going to see on how this evolution happened. All of this done because of the change process. As I said before, software change is not an option. Software change is happen naturally because of a lot of reasons that we already discussed before, and this is what actually happened in what we call as change mini cycle model. So they call it as mini cycle model because in software change, as if that we're having another round of development. So it's kind of having development inside development. So it started with the change request as shown here. Look. And then with that request, we analyze and plan for change. Analyze here because we want to check. First, we need to understand the request. And understanding might include what you call deciding whether this one is a genuine request or would be new features. So we have several categories of requests. So in the end, we can decide to proceed with this request or not. Okay, in case we decided, so this flow just is a happy day scenario. It's a normal flow. So we assume that the all the requests is accepted. So first, the request will go through into analyze and plan change. So during that time, we do a program comprehension. First, we understand the problem and we go straight to the source code. We understand the code, and we check which parts, which component of the system might been might been affected. Okay, if we implement that change, which is change impact analysis. Okay, and we also call this ripple effect. Now what is ripple? RIPPLE, ripple. In a ripple effect is something like on the water. If you tap on the surface of water, you will see the wave. That's ripple effect. Okay. So in software, we have that effect. If we change one component, somehow for sure there are some other component that might affect it with that one, especially when we deal with a component which might be called by other component. Yeah, perhaps you understand that. And then after we clear all of the related component with this impact analysis, and then we implement the change. This might implement the change means that we code the change. We do that in coding. This might involve restructuring of the whole structure of the system, for example. Yeah. And then change propagations of how the module works. Okay. And after we're done with the implementation, of course, as usual, we need to do testing, verify and validate. Okay, whether the one that we do is done correctly or not. If not, then further change required. If everything is done correctly, we update the document and then wait for another round of change request. So this is what happened in change mini cycle model. Okay, so okay, out there are two standards, okay, for this maintenance process. So we have IEEE, we have ISO. As I said just now, look, in IEEE, divided maintenance process in 7 phases. So we have problem identification, analysis, design, implementation, system test, acceptance test, and delivery. So all of this is basically Okay, similar to our planning, analysis, design, implementation, maintenance. Yeah, the stage, the development process. While the other one, ISO, look, ISO. What is ISO? ISO is stand for International
Organization standard.
Standard of, what is O? What is O?
Organization.
What is O, class? Ah, come on. International,
Organization.
huh?
Organization.
International Standard Organization. Okay. So yeah. So normally, okay, this ISO, if you work after this, and ISO is everywhere, like everywhere, like is in ISO normally their concept is more on the process, more on the what you call standardized process. Everyone is doing the same standard process. So in ISO approach looks, it's actually the same thing, but it's just that it's more emphasis on the process. Okay, looks, it started with process implementation, problem and modification analysis, modification implementation, maintenance review, acceptance, migration, and retirement. This actually the same thing. Okay, same thing. Look. Okay, so next let's we looks into this maintenance process of IEEE. So we have these 7 phases. Okay, we start from which one? This one. This is the entry point. Yeah, problem identification, analysis, design, implementation, system test, acceptance test, delivery, and then wait for another request, change request. This is MR is modification request, actually modification request MR, and then we have another round. Then this happen round and round, and then this is explained in this way. Okay, for each of these nodes has this explanation. Wow, some of you is listening music, is it? So we have here activity definition inside this, and then what are the input for every nodes, what are the outputs, and control. What's control? I think you understand what's input outputs, but control is refers to those items that provide control over the activities. Control is the control elements. How to explain this? Control is the control element, okay, that will identify process inside that particular node. Now, you will see this later in the detailed explanation of each nodes. And then we have metrics. Okay, this refers to the item that are measured during the execution of the activity. So each of these has its own item to be measured before we can decide to move to the next stage. Okay, look. For example, okay, this one, problem identification. So later, the following slide is basically explaining for each of these. For example, this one, problem identification, is this one. So explaining what's the input, what's the output, what's the control, what's the metric. And then we also have next analysis, same with design, and on and on. Okay, looks into this problem identification, the first one. Okay, what's the input of this one? The input, of course, modification request, DMR. Yeah, modification request, or sometimes they also call it as change request. Okay, CRM and MR. So input is modification request. Okay, so control mechanism for this, look, okay, uniquely identify modification requests, and okay, modification requests, and then enter modification request into repository. What do you understand what is control mechanism here? First, control mechanism here is to select, to make sure this is unique request, means that this is not repetitive request that has been repeated before, for example. Okay, because we don't want to entertain two same requests, yeah, at the same time, of course. And second, deciding which request into repository, which one kick out. So this is what is control here. Okay, and for each of these nodes, as I said before, we have metrics. Metrics is the calculations that we do to decide on the output. Okay, so for example, for this matrix, we have number of what do you call, number of modification requests submit, and number of duplicates modification requests. For example, this is what we're trying to avoid. Okay, duplicated modification requests. It will be wasting time if we do repeating the same thing, and time expended for problem validation. So problem validation is supposed to be done as quick as possible. Okay, so these are some of the metrics. You can read the details of this metric in our textbook. Yeah, details of the metric. This is just a simple calculation. It's not calculus. Okay, and finally we have the output of this process is validated modification request. Okay, and then process determination. So everything has been determined, has been identified. So what type of process will be done for this particular modification request. So next, this node move into the next node. Okay, again, they have input and they have output, they have control and they have metric. So input for this one is actually output from previous one, this one. Yeah. So output was validated modification request, and then as well as project document, repository information, and everything, because all of this, the document will be analyzed according to the request to see, okay, to see which part we can fix later on. Okay, so control mechanism for this is conduct technical review. Yes, because we have this document to be reviewed, verify that documentation is updated, verify a test strategy, identify safety and security issues. Okay. And metrics involved are listed here: requirement changes, documentation, error rates, effort per function area, elapsed time, schedule, error rates generated by priority and time. You can read this detail in our textbook. Okay, and the output of these features, because this is analysis. After analysis, normally we have lots of report of this analysis. We have feasibility reports, okay, for modification request. What is feasibility? Feasibility here is the is a report in terms of are we what do you call is that practical to
Can we do it or not? Like
sorry,
it's like the possibility. It's like, is it operatable or?
yes, one of them is operatable. One.
Yeah.
Second, because after this analysis we know in terms of software maintenance, after this analysis we know if the fix if is that worthy for us to fix that. Okay, because every fix might consume cost, okay, timing cost, financial cost, but some fix maybe only give benefit to only small number of users. For example, maybe only 1 or 2 users. So in that case, maybe not really worthy. Yeah. So and then in terms of technical, do we have enough skill to fix that or something like that? So this is what is mean by feasibility report. Yeah. And then we also have detailed analysis reports in terms of which component related and this and that. And then preliminary modification reports. Preliminary is just a glance through, okay, a glance through of possible modification, possible modification required for a particular component. And then in relation with that, we started to plan the test strategy, and then finally implementation plan is the time when we do implement that changes. We do the fixing part, the coding part, and we move to the next nodes. Yeah. Okay. If here in analysis we mention what to change, here we mention how to change. This is what's the difference between analysis and design. And the rest, I think just similar to what we have in software development. Okay, but for this one, for design, okay, we have what was the input. We have project document, analysis phase output, source code databases. So now we have the source code. So so what we do here with the source code, we conduct software inspections, verify that design is documented and complete traceability of requirement to design. Yeah, we trace back this here we have STD, we trace back with SRS. Yeah. Okay, and then of course together with all the metrics, and finally then this is the output. You can read them here. So after design, what we do? Coding. So because in design we might have already we will have detail what they call implementations detail. For example, we have a complete list of a class list, and then the related methods, the variable need to be changed. Okay, and then so this is actually useful for programmers. Okay, later I will show you. Okay, I will show you real document. If not today, maybe next time. Okay, the real SRS and STD. Okay, just to change your understanding, because before this, most of people might think the hardest job in the software development is coding, isn't it?
Yes.
Isn't it? Yeah.
Yes.
This is
Yes.
okay. This is
Coding.
what.
This is the
Yeah.
general opinion.
Yeah. General opinion about software development. People scared of coding. Yeah. But do you guys know that the minimum requirement to be a programmer is what? Is only would be certificate in Python, for example. So you don't have to take even bachelor degree to become programmer. That's basically. But somehow that job, okay, which is people think as the hardest part, is given to this. I'm not downgrading them, but programmers, it's not supposed, okay, to have that kind of difficult job. Okay, because actually if all the development stage is really follow according to software engineering stage, okay, we started with the requirement, we produce SRS, okay, and SRS just list of, I'll show you later. SRS come with full list of what the features software is, what of the features that the software need to be provide, okay, and SDD mention how to develop that features. So in SDD we will have details name. Okay, the details may be up to the level of we suggesting class name together with all the related variable attributes, and as well as all methods. Okay, and inside the methods also together with all formula and everything. So programmer's job basically is simple. Programmers not even have to think what are the names of the class you should put, what are the names of the variable. Okay, but somehow this is not in real practice. What happened out there mostly, the what they call the system analyst might have a very brief system requirement analysis, and then in the SDD what they have is just a simple drawing of the form. This is what I got last time, and then passed to me as a fresh graduate that time working as a programmer. So programmers is the one who will have to crack our head to decide what class need to be developed, what variable need to be created, what methods to be created, and how one class will work with another class in the end to fulfill the specific requirement. So in the end, all the burden is passed to programmer. So given the one that I said, most of the time programmers job is given to new staff, and some of them has a low only certificate in programming, for example, and this is why some of the project is not really successful. Yeah, because it's just wrong practice of software engineering. So later I will show you the real SRS and the real SDD. If you see the SDD later on, you will see how easy is actually coding job. Okay, programmers just not even have to think the name of the class. Can you imagine that? Now, even in your programming subject, you need to decide, is it what type of variable need to be used. But actually programmers not even have to think up to that level. Okay, then implementation. So after implementation, what do we do? As usual, we do testing. Okay, you can read here. So the input of the testing, of course, the system itself, and then the documentation. Test readiness review report. This is basically just to what they call endorsement from the previous previous stage, saying that this software is ready, this project is ready to be tested. And tested for this time is actually what we call as regression testing. Okay, so you can read here system testing, and finally acceptance test, where finally is to decide whether the fix is going to be fit into system baseline. Okay, what is baseline will be discussed later in configuration management chapter. Okay, and finally, of course, delivery. Okay, you can read this. Yeah. So as I said just now, yeah, I just repeat. So each of these round has its own input, output, control metric. So explanation. So all of them is done one by one. Okay, having the same explanation for each of them. Okay, so on top of IEEE, as I said just now, we also have ISO. Okay, but here, look, as I said before, ISO more in the form of process. Yeah. So so yeah, and looks even more simple. We have process implementations. Yeah, it's almost the same. Yeah, it's just a bit of different setting. Problem and modification analysis, and then modification implementation, maintenance review acceptance, and finally the migrations or requirement. Yeah, retirement. Okay, so again, this is explained in the same style. We just read them. Okay, even more simpler. I encourage you to read this. Yeah, and yeah, okay, and the last portion is this one, software configuration management. Okay, maybe just a bit again for this one. Even though in the next class we're going to use another slide that I already uploaded to put up last time, but I encourage you to read this portion as well. Okay, the reason why I don't want to use this slide because I noticed that the what you call the presentation of this slide is not it's not really what you call interesting compared with another one. Yeah, yeah. So anyhow, the information here is I think it's also good for you as your knowledge. So you read this as a preparation before I explain this chapter by using another slides. Yeah. Anyhow, so what is configuration management? Just a bit introduction. Okay. Configuration is not it's not configuration that you might understand regarding setting. Yeah, it's setting, but it's not setting of what you call data type. You know, the parameters. No, it's not. It's not that type of configurations. Configuration here is more on the setting in terms of development approaches. Yeah, this is what is software configuration management. For example, um, for example, in a software development house, we have lots of programmers. Okay, and we have lots of parts of the source code. Okay, that is underdeveloped by these programmers. And there are times when more than one programmer is working on the same component of the source code, for example. Yeah, let's say component is component A in at the end of the day has two versions, A1 and A2. Okay, the questions now is which one that we will be choose, okay, to be included in the next release. You know what I mean? Okay, I repeat. In a software house, okay, we have lots of programmers, lots of components to be worked on in software development. And it's happened when more than one programmers are working on the same module. So in the end, we have more than one version of the software component, more than one version of the software file. So at the end of the days, we need to compile this component into completed system. But the question is, which one is the one that we're going to use? So this kind of question is actually answered by software configuration management. Okay, to decide which one is related to particular baseline. So this is what is baseline. Yeah, baseline is basically a lines up of the software component that is chosen based on certain features, certain change plans. Okay, so we're going to discuss that later on Wednesday. Is it your class? Yeah, Wednesday. So what's time now? Oh, 3:20. So any question, class? No.
Doctor.
No, sir.
No.
Okay, so so in the end, so this will be covered again in next slides, next sections, next chapter. So, but I encourage you to read this. Yeah, just a glance through it. And then also because we're also going to discuss the request workflow as well in the next chapter and summary of this portion. So basically for today's discussion, we only discuss up to here. Yeah, and the rest, these two, is included on the next chapter. Okay, if there is no questions, yeah, I prepare quiz for you to answer that in Putra Blast. Have you checked? Nope. No, just kidding. No, nothing.
You scare me.
I didn't answer because I had to go to Butra Plus to see the
Heart
quiz.
attack.
I just want to check you guys is still there with me because I feel like I'm
No.
kind of talking lonely here.
No. I mean, we didn't answer because we went straight to Butra Plus.
No,
We were scared.
not this time. Yeah. Okay, so until we meet again, this I think if there is no question, so we meet again this Friday. Yeah. Okay, so I
This
think
Wednesday.
Wednesday. Yeah, no Friday, Wednesday. So yeah.
Okay.
So until see you again. So student,
Sorry, Doctor, can you
Yes.
share this slide in Putra Blast?
yeah, already there in Putra Blast.
Oh,
Yeah, it's already uploaded there. Yeah.
it's
Okay,
different.
so see
Sorry,
you then.
sorry for interrupting. I would like to ask about the group
Okay.
project. Is there any
Okay.
updates when we'll be able to start it?
Oh yes, I will. Yeah, I will upload later the details instructions later. But for the time being, have you decided your group member?
We're not sure about the number of group members, Doctor.
Yeah, the limit.
Okay, I'll let you know later. I will check on how many students we have. Then after that, maybe we can. So I will ask one of you to create Google form. Okay, so then you can register your name there according to your group member. Yeah, I will let you know later. Sure.
All right, Doctor.
Okay, Doctor. Thank you very much.
Okay,
Okay,
guys. So
Doctor. Okay.
see you this Wednesday. Okay, see you then. Bye.
Okay.
Okay, thank you.
Bye.
Bye.
Assalamualaikum.
Assalamu
Good day. Bye.
Assalamualaikum.
Yeah.
Thank you.